Let's start, everybody. For the remaining topic for the midterm grading period, we will be discussing antifungal agents. In this regard, we are going to tackle the pharmacological agents that can be used in different fungal infections. Basically, the flow of our lecture is as follows. First, we will have a brief review about fungi kasi ito yung target organisms ng mga drugs na itatakal natin this morning. Kaya i-recall natin yung mga natutunan niya about fungi. Next, we will discuss the different targets for antifungal therapy, meaning to say, we will indicate the common proteins and other entities or macromolecules that could be targeted by antifungal drugs. And then finally, we will discuss antifungal agents. So sa last portion natin i-discuss yung mga specific drugs considered as antifungals. So first, let's have brief background about fungal diseases and also fungi as microorganisms. Last semester nag-micro kayo, so I bet meron kayong konting idea or nare-recall about fungi. Number one, the fungal kingdom or the Mycetae kingdom consists of different organisms like yeasts, molds, rusts, and also mushroom. Technically, when we check on fungi, yung mga characteristics sila are the following. Number one, they are so-called as saprophytic. Have you heard at least the term saprophytic before? Narinig nyo na siya dati? So anong ibig sabihin natin ng saprophytic? Pag sinabi nating saprophytic or saprophytes, ang mga fungi, they utilize decaying organic matter. So they utilize decaying organic matter as their sources of energy. So nagbe-base sila sa mga decaying organic matter as their energy sources. So for example, ito yung mga decaying woods, 'di ba? Sa mga kahoy nakikita natin sila, and also in some cases sa soil o sa lupa. Can you follow so far? Hmm? Okay, good. Next, some fungi are also considered as opportunistic. What do we mean by opportunistic? Guys, usually, majority of fungal organisms do not cause diseases. In fact, some are beneficial to us. However, there are cases that fungi become pathogens or nagkakos ng diseases. But, in healthy individuals like us with healthy immune system, usually ang mga fungi, they don't cause disease. However, to some patients that are, for instance, immunocompromised o yung mahina yung immune system, this fungi can eventually cause disease or infection. So ibig sabihin, may mga klase ng tao na mahina ang immune system na mabilis magkasakit because of fungi, pero sa mga healthy, hindi naman. Okay? Ano ba yung mga example ng patients na immunocompromised? Can you give some cases ng pasyente na masasabi nating kompromiso or mahina ang immune system niya? Ano yung mga example patients? Sige nga, can you give me some? Sige, ano yung idea nyo sa mga taong mahina ang immune system? Tulad ng mga anong klaseng tao? Number one, sige, may idea? Okay, so pwede. Those patients with existing infection. So sa mga pasyente with existing infection, potential ultimate cause is pwede silang yes, may cancer at nag-undergo ng anti-cancer therapy. Patients that undergo anti-cancer therapy, mahina immune system nila because the drugs can weaken the immune system of a patient. Tama, cancer patient and may existing infection. What else? Mga taong may yung sinabi ni Mr. Hans Batak, may existing infection, tama yon. For example, may HIV/AIDS. Ang taong may HIV/AIDS, compromised din ang immune system. Ay, tama yon. So yun yung mga example nating cases na pwedeng mahina ang immune system. Kaya strictly monitored sila kasi mabilis sila magkasakit. And then finally, some fungi are even obligate parasites. When we say obligate parasites, for their survival, they need host cells o kaya host organism. Relative to our body sa katawan natin, ang example fungal parasite na pwedeng mag-house or mag-live sa atin ay mga dermatophytes. Later, I will explain kung bakit dermatophytes ang example natin ng obligate parasite sa atin, sa mga humans or mammals. And the field of science that deals with the study of fungi, this is quite easy. Mycology, di ba? Mycology yung tawag natin doon sa field of science or medicine. Moving on, so we have, sa mga succeeding slides, we have common classes of fungi with the corresponding diseases or infections that they can elicit in our body. So first stop, let's discuss dermatophytes. When we say dermatophytes, as the term suggests, dermato, maiisip natin pag derma or dermato, the integumentary system. Yes, that's correct because these are fungi that can cause infection or that live or house in the integumentary system, in the skin, in the hair, and also in the nails. So ano yung mga specific genera ng dermatophytes na nagkakos ng or nag-house sa ating integument? So kasali dyan ang mga microorganisms called trichophyton. Okay? Number one, we have trichophyton. Aside from trichophyton, we also have epidermophyton, and then we have microsporum. Microsporum. So these are genera. So kung handwritten siya, naka-underline siya. I repeat, common genera are trichophyton, epidermophyton, and microsporum. These are dermatophytes. Now, bakit sila kino-consider, if you could remember, bakit sila kino-consider na obligate parasites? Mind you, for them to survive, they need to house in the skin because the nutrient that they need sa skin natin ay keratin. Dermatophytes obtain nutrients by attacking cross-linked proteins called keratin. Kaya usually this fungi can cause infections affecting our skin. So ang tawag natin sa mga dermatophytic infections ay dermatophytosis. Di ba yun yung tawag natin medically speaking, dermatophytosis. Of course, ang plural form niya ay dermatophytosis. So basically, yan yung tawag sa dermatophytic infection. Now, this is a medical term, dermatophytosis. Meron tayong another term related to dermatophytic infection. Based on your stock knowledge sa micro, ano yung common term sa dermatophytosis? Siguro pag nilagyan ko ng starts with letter, magkakaroon kayo ng idea. It starts with letter T. Anong tawag doon? Yes, very good, tinea. Ay, tinea infection. Narinig din yung tinea dati? Nice. So ang tawag doon guys ay tinea infection. So para lang meron kayong idea, para lang ma-correct nyo kung sakaling meron kayong misunderstanding about tinea, guys, ang tinea ay tawag sa sakit. Okay, sa sakit, sa infection. It's not a scientific name. It's not the cause of dermatophytosis. So AKA lang siya. What I mean to say is whenever you write tinea, you should not write it in scientific name form. Kasi yung iba ang ginagawa dito, halimbawa pag gumagawa sila ng assess ng task, ginagawa nilang italicize yung tinea pero hindi siya scientific name. Kaya ang tinea pag sinulat nyo, usual lang siya, tinea, kasi infection siya. The ones that can cause tinea are the TEM organisms. Did you get that? Nice. Next, after natin sa dermatophytes, tandaan nyo, dermatophytes sa skin lang, sa skin. Also, we have molds. The most common organism or fungus na mold that can cause fungal infection ay ang Aspergillus species. Aspergillus species. So marami tayong specific species ng Aspergillus that are molds that can result to fungal infection. In general, ang tawag natin sa fungal infection caused by Aspergillus ay aspergillosis. Siguro narinig na siya dati. Now, ano yung common route of entry or exposure natin sa mga Aspergillus species? Number one, pwede siyang inhalational. Basically, inhalational means na-inhale, nakapasok through the nostril. Kaya ang target organ ng Aspergillus ay lungs. Ay, target organ ay lungs. Kaya pag affected ang lungs, inhalation yon, lung infection caused by Aspergillus. Next, pwede rin naman, bukod sa inhalation, pwede ring ingestion, nakain. Ay, nakain. Bakit pwedeng route of exposure ng tao ang ingestion? Kasi merong mga mushrooms containing Aspergillus species, mga mushroom na akala ng iba edible pero infected na pala ng Aspergillus or contaminated with Aspergillus. Now, pag ingested siya, ang target organ sa katawan ay liver. Ay target organ sa katawan ay liver, causing liver cancer. Again, causing liver cancer. Ano yung related toxin dito? Actually, narinig nyo na siguro siya dati. I'm not sure. Halimbawa, kasama dito na may Aspergillus yung aflatoxin. Narinig nyo na yung aflatoxin, guys? Aflatoxin. Familiar kayo or no? To be honest. Okay, very good. So familiar kayo. So aflatoxin. Di ba yung aflatoxin? Galing siya sa mushroom. So nagkukos yun ng liver disease kasi Aspergillus yun. Next, punta naman tayo sa yeast. The most common fungus under yeast na nagkukos ng fungal infection ay letter C, A. Scientific name na CA. Ano sa tingin niyo yung CA? Isang scientific name lang siya. Nice. So the answer is Candida albicans. Tama yon. The most common fungus na yeast that can cause fungal infection ay Candida albicans. Guys, typically, Candida albicans is part of our normal flora. We have it. Meron tayo niyan. Often, Candida albicans could be found na nakahouse sa oropharynx natin, sa gastrointestinal tract, in females sa vagina and also surrounding skin. With that being said, ang Candida albicans hindi siya usually nagkukos ng fungal disease kasi normally housing siya sa katawan natin. However, nabanggit nga natin, in some cases, if an individual is immunocompromised, pag mababa o mahina ang immunity niya or immune system, Candida albicans could become pathogenic or disease-causing. Pwede siya mag-cause ng sakit. That's why Candida albicans could affect, halimbawa, vagina sa babaeng immunocompromised resulting to vaginal yeast infections, and also pwede rin siya mag-cause ng oral thrush or singaw. So what I mean to say here is pag humihina ang immune system. But if we have competent immune system, normally this does not cause disease. Okay? So yun yung example natin sa yeast, Candida albicans. Overall, guys, these are the common fungal diseases with their corresponding causative agents. So ano yung marirealize natin dito? Number one, common na fungal infection ay dermatophytes, meaning sa skin. Kaya kung iisipin nyo, maraming antifungal agents na topically administered. So i-discuss natin siya isa-isa mamaya. Pangalawa, there are fungal microorganisms that can attack our internal organs, kaya meron tayo mga systemically administered, particularly sa mga immunocompromised patients. Ay, yun yung mga tatandaan nyo. So with that, tapos na tayo sa overview ng fungi. Can you follow so far? Yung iba, kayo, kamusta kayo? Okay, nice. So we are finished with overview of the fungi. Next, for us to appreciate the actions of antifungal agents that we are going to tackle later, we have to note the drug targets. Diba? Important ang drug targets for us to understand kung magiging beneficial ba or toxic ang actions ng medications. With that being said, let's enumerate the different targets or biochemical targets for antifungal therapy. Based on scientific evidences, there are 5 potential biochemical targets that can be employed by pharmacological agents. So pag ito ang tinarget, may antifungal effect, in other words. Number 1, it is essential to target the cell membrane of the fungi. Very important ang cell membrane, hindi lang sa fungi, kahit sa ang cells. Because ang cell membrane, it provides partition sa isang cell from another, and also it facilitates transport of different nutrients. So based on that info, important ang cell membrane. So if we will target the cell membrane of the fungi, we tend to kill somehow the fungi. That's why merong antifungal effect. Kaya mamaya pagpunta natin sa mga drugs, kapag nabanggit ang cell membrane, may idea na kayo kung magkukos yun ng beneficial effect. Next, also based on your knowledge in the structure of fungi, meron silang cell wall. Kaya potential target din ang cell wall. Meron tayo mga antifungal drugs na cell wall naman ang target. Also, we have DNA synthesis. What's the essence of targeting DNA synthesis? Please remember, in biochemistry, di ba, ang DNA synthesis is the prerequisite in the formation of mRNA. This is important in the formation of mRNA, and eventually this is essential in the synthesis of proteins. So in short, if we will target DNA production, we will inhibit ultimately protein synthesis dito sa mga fungi. So pag walang proteins, eventually, they will die. Eventually, pag tumagal. Kaya, target din siya ng antifungal drugs. Nasusundan? Okay, nice. And then we have mitotic process, the cell division, and then finally intermediary metabolism in the synthesis of certain compounds or uh, substances in the fungal cell. So overall, these are the biochemical targets for antifungal therapy. Later, as we go through our discussion, may encounter kayong antifungals na isa dyan ang tinarget. But let me emphasize that amongst these biochemical targets, maraming commercially available, there are numerous commercially available antifungals that target the cell membrane. That's why we will focus on cell membrane later. Ay magpo-focus tayo dyan. This figure summarizes the different classifications of antifungal agents with their target structures in the fungal cell. So meron tayong nagta-target nga ng cell membrane, ng cell wall, ng protein eventually because of targeting DNA synthesis and so on and so forth. Iisa-isahin natin sila mamaya. Okay? Next, as I've said, sa lahat ng mga biochemical targets, numerous commercially available agents are the ones that can target the cell membrane. Kaya at this juncture, let us discuss the cell membrane of fungi. Pwede na tayo mag-start sa cell membrane? Pwede na? Good. So dito tayo sa cell membrane. Guys, there are numerous studies or researches about fungal cell membrane. Ito ang challenge before. So let me tell some story. The challenge before was if the drug will target the cell membrane, it's quite risky. Kasi ang mammalian cells like us, animal cells, meron ding cell membrane. So pwede ma-compromise ang selective toxicity. Remember, selective toxicity sa anti-infective agents, lagi natin siya magagamit. Okay? So going back, yun ang challenge. Pag tinarget ang cell membrane ng fungi, pwede ma-target, ma-kill din ng gamot yung ating sariling cells, the mammalian cells, because both of us possess cell membrane. However, because of deeper studies, it was realized na meron palang different components ang cell membrane ng fungal from mammalian cells or animal cells. So bago natin i-discuss ang sterol and also, or sorry, cholesterol and ergosterol, let's explain first the importance of sterols in the cell membrane. One of the components ng cell membrane ay yung mga sterols or steroidal substances. You can tell if a certain structure is a sterol if it possesses the 4 cyclic ring structure, just like the ones presented in the PowerPoint. So ang sterols ay important because they provide stability ng cell membrane. Again, sterols provide stability of the cell membrane. And aside from that, it provides transport of transport of substances because of stability of transport proteins. And then it aids also with the activity of enzymes in facilitating different chemical reactions. So with this, we can infer that sterols are really important components ng cell membrane natin. So if we will target sterol, pwede nating mapatay yung fungi. And based on studies nga, it was concluded na magkaiba pala ang sterols ng fungal at animal cell. Sa fungal cell, ergosterol ang present, ay ergosterol. While in the mammalian cells like us, cholesterol ang present sterol. Malaking bagay ito to be able to establish selective toxicity. Ay why? Because kapag magdi-discover ng antifungal or if we will develop antifungal agents, as much as possible, the ones na gagamitin dapat should target ergosterol. Because if cholesterol will be targeted, magkakos siya ng adverse effects sa tao. Okay? So we have the structures of cholesterol and ergosterol shown. The major difference is found in ring B side chain. Ang ring B, FYI, is this one. This is ring B. So dito na lang tayo mag-focus sa ring B. As I've said, ang difference nila ay sa side chain ng ring B. Ano ang major difference? That is the presence of double bond. Yan yung major difference sila. I repeat, that is the presence of double bond and also yung methyl group sa side chain. So yun lang ang difference ng ergosterol and also cholesterol. Kaya when we discover or develop antifungal, as much as possible, we have to focus on targeting ergosterol. And in relation to that, it was also studied very carefully how ergosterol is being produced by the fungal cell. Bakit important na balikan natin or i-discuss natin rather kung paano nasisynthesize ang ergosterol? Because there are numerous agents that can target this pathway. Kaya please remember this pathway kasi marami tayong drugs na i-discuss mamaya that would target this pathway. Okay? So meron tayong dalawang major reactions na ifo-focus sa slide na to because these two reactions will be targeted by drugs. Number one is via the enzyme squalene epoxidase. Again, first, we have the enzyme squalene epoxidase. The enzyme squalene epoxidase is responsible for the epoxidation of squalene. So squalene is this one, which is not yet cyclic hydrocarbon. When we say not yet cyclic, wala pang ring structure kayo or enclosed structure na makikita sa kanyang illustrated structure. As you can tell, wala nga, di ba? Wala. Very important ang epoxidation of squalene for us to synthesize sterol already, for us to synthesize the fourth cyclic ring structure. So the important enzyme for that is called squalene epoxidase, resulting in the formation of squalene epoxide. Do you know what epoxide is? Do you know what epoxide is? What is epoxide? Okay, so ang epoxide ay isang cyclic ether. Apparent ba sa structure ng squalene epoxide na may ether? May ether ba dyan? May ether ba dyan? Okay, so ito yung ether. So ang tawag doon ay squalene epoxide. Very good. Na-discuss na natin siya sa metab, di ba? Now, kapag na-form ang squalene epoxide, na tawid na, na-overcome na natin ang essential step for us to produce cyclic ring structures or sterols. So with epoxidation of squalene, that would eventually lead in the formation of lanosterol. Lanosterol is the first sterol. Siya yung kauna-unang sterol na napoproduce. At pag na-produce na ang lanosterol, the next step would be demethylation. The next step would be demethylation reaction. Pag sinabi nating demethylation, sa drug metab na discuss rin natin ang demethylation, we are going to remove a methyl group, di ba? We will remove a methyl group. And removal of methyl group could be observed on the 14th carbon. Again, it can be observed at the 14th carbon atom found in the lanosterol's structure. So saan siya makikita? So para mabilis tayo, in the interest of time, ito yung 14th carbon atom. Okay, ito yung 14th carbon atom. So the goal here is to remove the methyl group attached to the carbon. So that is being aided by the action of 14-alpha demethylase enzyme. Mind you, class, that 14-alpha demethylase is an oxidative enzyme classified under the cytochrome family. So cytochrome family siya. Particularly, ang AKA ng 14-alpha demethylase is CYP51. Again, that is also known as the cytochrome 51. Wag na wag niyong kakalimutan na cytochrome ang 14-alpha demethylase kasi related ito sa mechanism of action ng isang grupo ng antifungal that we are going to discuss later. Okay? So moving on, guys, if cytochrome ang nagme-mediate sa chemical reaction na to, therefore, what kind of chemical reaction is happening here? Is it oxidation, is it reduction, or hydrolysis? Pag cytochrome ang nagme-mediate. Okay, so oxidation ang nangyayari dyan. So in short, ang lanosterol will undergo oxidative reactions, series of oxidative reactions that would eventually lead in the formation of, again, ergosterol. So yan po ang pathway, yung shortened pathway on how ergosterol is being produced. Mind you, the ones that I emphasized, yung mga targets ng drugs na itatakal natin mamaya. So yan po ang synthesis. Going back, meron tayong dalawang important steps na kailangang matandaan, epoxidation and oxidation. Epoxidation of squalene resulting to epoxide and eventually lanosterol, which is the first sterol produced. And ang lanosterol, hindi pa siya yung final component ng fungal cell membrane. It's ergosterol. Kaya it must be targeted by cytochrome. Cytochrome 51. Anong ginagawa ng cytochrome 51? Ano ang inaalis niyang functional group? Anong inaalis niyang functional group? Anong i-remove niyang functional group doon sa substrate? Yes, it's methyl. On what carbon atom? Good. That's 14 carbon atom. Yes, very good. Overall, guys, tapos na tayo sa biochemical targets. As I have made mention, ang binigyan natin ng emphasis at this point ang cell membrane. Pero may iba pang nagta-target ng ibang biomolecules sa fungi. Mamaya matatakal natin sila. Marami kasi ang cell membrane, kaya doon ako nag-focus in the meantime. Next, nandito na tayo sa tough stuff. Let's have the different examples or classes of antifungal agents. Apparently, we have 8. I-discuss natin ito isa-isa. We will focus on their chemistry, their mechanism of action. Merong relevance yung chemistry nila sa kanilang action or sa kanilang application in different fungal infections. So first, dun muna tayo sa superficial. Superficial or yung mga topical antifungal agents. Common sense, topical antifungals are the ones that can be used for fungal infections affecting the skin. Therefore, ang maiisip natin dito, they are often used for tinea infections. Nasusundan ako, guys. They are being used for tinea infections. That's why it's stated here, these agents are directly applied to the affected surface areas of the skin. However, you have to realize that one of the most challenging routes of administration sa gamot, like antifungals, ay sa skin. Bakit? Kasi pag topical administration, ang balat natin, it serves as a barrier itself. Kaya mahihirapan ang drug para mag-permeate at pumasok or ma-absorb. So that's why challenging siya. Kaya to be able to address this issue, we often combine antifungal agents with other drugs para ma-enhance ang penetration ng antifungal. So ang tawag natin often sa mga adjuvants o yung kino-combine sa mga antifungals to enhance entry sa ating balat, particularly sa keratin, mga keratolytic. Are you familiar to keratolytic agents? Ha? Very good. So that's why pag nakakita kayo ng mga medications na antifungal, na topical, lagi may plus, lagi may kasamang plus. So mamaya mabibigyan ko kayo na example ng mga keratolytic. So ang point ng keratolytic, siya ay magbubukas ng skin para ma-allow ang pasok ng mismong antifungal. Kasi ma-defeat yung purpose ng antifungal kapag hindi siya makapasok doon sa loob kung saan kailangan yung gamot. So let's discuss the different examples of topical agents. Yung topical part, madali lang siya. Actually, memorization lang siya. At marami dito na discuss na sa anti-infectives. So para may idea kayo sa outline, may dalawang grupo tayong i-discuss dito. Ay, dalawang grupo. Number one are the fatty acids. Again, number one are the fatty acids. And then second, we have phenol derivatives. We have the phenol derivatives. Siguro sa phenol may idea na kayo kasi natakal na nga siya sa anti-infective agents. So start tayo class sa fatty acids. First, kilalanin muna natin kung ano ang fatty acids. Sa biochem, ano ang fatty acid in terms of structure? As an organic compound, anong klaseng organic compound ang mga fatty acids? Sila ba ay alcohol? Sila ba ay ether? Sila ba ay aldehydes? Sila ba ay ketones? Sila ba ay sila ba ay carboxylic acid, ester, amide? Ano sila? O yung iba, anong idea nyo? Anong idea nung iba? Ano ang fatty acid? So tama, siya ay carboxylic acid. Ay carboxylic acid siya. Ang carboxylic acid ay merong formula na, ano formula ng carboxylic acid? Anong formula ng carboxylic acid? Okay. So ang formula ng carboxylic acid ay RC double bond OOH. Okay? Wherein ang R group is composed of long chain hydrocarbons. Okay? This is composed of long chain hydrocarbons. Ang hydrocarbons or long chain hydrocarbons, this is the portion of the fatty acid na nagre-result or nagkokos ng lipophilicity niya. Kaya ang mga fatty acids, in short, they are said to be lipophilic. So what's the importance of mentioning na long chain hydrocarbon ito at lipophilic? May kinalaman siya sa molecular action niya, sa mechanism of action. Alam niyo ba sa chemistry yung principle na like dissolves like? Very good. So ang fatty acids, because of their long chain hydrocarbons, they are lipophilic. That's why they can easily permeate the cell membrane. So they can easily or easy permeation sa cell membrane. So they promote easy or light permeation sa cell membrane that would eventually enhance fluidity of the cell membrane, thus causing destruction. Okay? Thus causing destruction of the cell membrane. So I repeat, since these are lipophilic, like dissolves like, makakapasok siya easily sa cell membrane, destroying the cell membrane because of enhanced fluidity. So that's the mechanism of action of fatty acids. Did you get the MOA? Ha? Okay. So examples are as follows. So yung mga susunod na slide, i-guide ko kayo. Ito yung mga examples natin. Number one, sebum. Ang sebum ba ay endogenous? Nagagawa ba natin ito sa katawan natin? Yes, meron tayong sebum sa katawan natin. So ang sebum, this is an acidic fatty acid or fatty substance in and on the skin and functions as a natural antifungal agent. So ano napapansin nyo? Kahit may mag-house na fungi sa ating balat, hindi usually hindi siya nagmamanifest kasi we have sebum. Siya ang bahala because antifungal na siya by itself. Now, syempre may mga sitwasyon na sebum itself is no longer enough. Kaya ang tendency, we need facilitation of other stronger antifungal agents, like the ones na naka-enumerate sa mga succeeding slides. We also have propionic acid. So na-discuss na ata ito before, but kung i-recall nyo, ang propionic acid ay fatty acid din siya. So just check the internet kung anong structure niya, magre-reflect pa din sa general rule natin about fatty acids. So propionic acid is a clear corrosive liquid with a characteristic odor, and we have a salt form for propionic acid that is zinc propionate. Usually, adhesive tape siya to enhance contact time, okay? To prolong contact time, thus greater antifungal activity. So we have propionic and also zinc propionate. We also have other agents like sodium caprylate. This is the salt form of caprylic acid that comes from coconut and also palm oils, which are lipophilic, okay? And then zinc caprylate. However, this is said to be unstable to moisture. Kaya ano yung ating takeaway sa zinc caprylate? If you will apply zinc caprylate sa skin, make sure na, ano ang reminder mo dito bilang pharmacist? Dapat dry yung balat. Okay, dry yung balat. As much as possible, tuyuing mabuti yung affected part para ma-enhance yung action niya. Nice. So itong topical, sabi ko nga, madali lang siya compared sa mga succeeding topics. Next, we have undecilenic acid. Undecilenic acid comes from castor oil. Ang castor oil ay made up of fatty acids as well, kaya highly lipophilic siya. This is traditionally used in the treatment of athlete's foot, which is also an example of tinea infection. You can see in the structure of undecilenic acid na reflective pa din siya doon sa general structure na carboxylic acid na may long chain hydrocarbon. So because of the long chain hydrocarbon, this makes undecilenic acid lipophilic, thus providing easier permeability sa cell membrane natin. Next, we have salicylic acid. Salicylic acid has dual purpose. Ay meron siyang dual purpose. Number one, meron na siyang antifungal effect, antifungal activity. And aside from having an antifungal activity, meron din siyang keratolytic property. Ano ang realization natin about salicylic acid? You can infer here that salicylic acid alone as a topical antifungal can be used. Kaya sa butika, 'di ba, meron tayong available na salicylic acid alone na antifungal. Pero may mga cases na ang salicylic acid kino-combine sa ibang antifungal. Kasi ano yung contribution ng salicylic acid? Ba't siya kino-combine sa antifungal? Because of its keratolytic effect. Important ba ang keratolytic action to enhance antifungal effect? Yes, okay. Very important. Kaya pag pupunta kayong butika or kung may butika kayo, tignan nyo na lahat ng mga antifungals na meron kayo na available, na topically administered. Kasi makikita nyo doon yung kanyang use, nakalagay, antifungal and keratolytic. O kaya antifungal, ganyan. So actually, hindi lang siya sa antifungal agents eh. Yung mga ina-apply sa balat. Diba? Yung mga anti-acne drugs. Kaya yung iba minsan sinasama ng keratolytic para ma-enhance ang penetration. Next, na-discuss na to before, ay na-discuss na siya. We have resorcinol. So balikan nyo na lang po ang resorcinol. Diba? Meta-position ang hydroxyl groups niya. So meron siyang antiseptic and keratolytic. Next, benzoic acid. Regarding benzoic acid, it possesses an antifungal effect. However, its limitation is yung penetration niya sa deeper layers ng balat containing virus. May mga keratin tayo on deeper layers of the skin. In some cases, if the fungal organism has reached that layer, hindi siya kayang pasukin ng benzoic. That's why this is often mixed with a keratolytic agent. Hence, we have commercially available antifungal agent or antifungal drug preparation in the name of Whitfield's ointment. I'm not sure, sorry, hindi pala kayo face-to-face, no? Pero nung college kami, ginawa namin ito sa actual laboratory sa dosage forms, Whitfield's ointment. Pero narinig yun na to at least dati. Nice. You can check the ingredients of Whitfield's ointment. Number one, we have benzoic acid. Number two, salicylic acid. So alam natin kung bakit may benzoic kasi antifungal nga siya. And to enhance penetration, sino ang kailangan to enhance penetration? Salicylic because of its keratolytic activity. And also we have petrolatum base. Kasi nga, bakit kailangan petrolatum base? Ang petrolatum is hydrocarbon base ito, hydrocarbon base. So pag hydrocarbon base, so ma-employ natin ang distribution or yung tamang pagmix ng benzoic at salicylic kasi lipophilic din sila in general. Kaya okay yung pag-spread sa balat natin na lipophilic din. Okay? So yun po ang ating application ng benzoic acid. Next, punta naman tayo sa phenols and their derivatives. By the way, siguro inaas nyo, Sir, bakit kaya lipophilic yung mga fatty acids? Bakit sila ang kailangan? Bukod sa pag-target ng fungi, ang balat natin ay lipophilic din. Okay? Ang balat natin ay lipophilic, kaya as much as possible, oil-based dapat ang nilalagay sa balat for easier absorption or relatively faster absorption. Take note of that. Next, we have phenols and their derivatives. The mechanism of action of phenols against microorganisms like fungi was already discussed sa anti-infectives. Kaya it's your job to recall the mechanism of action. So punta tayo sa mga specific examples. Number one, we have haloprogene. So you can see that in the structure of haloprogene, meron siyang halogen na chlorine atom. So meron tayong tatlong chlorine atoms here. And then we have ether functional group, which could be found here. However, the major limitation of haloprogene is expensive siya, mahal, compared sa ibang commercially available. Next, we also have clyoquinol. This is often used as a substitute for iodoform as an antifungal agent topically administered. Iodoform was also discussed sa anti-infectives, so balikan nyo na lang siya. Next, we have cyclopirox or lamine. This is considered as the agent of choice. AOC means agent of choice for cutaneous candidiasis. So halimbawa, those affecting the skin, tinea corporis, tinea cruris, etc. So meron kayong, I think, idea sa iba't ibang types ng tinea infections. Ang basis lang nito is yung location, kung saan part ng katawan affected. So meron ata akong slide dito mamaya indicating different types of tinea. So mache-check natin sila later. Also, this is considered as the second-line agent in the treatment of onychomycosis, which is the ringworm of the nails. So basically, yan po ang mga topically administered antifungal agents. Okay? So tapos na tayo sa topical antifungals. So next stop tayo. Actually, hindi lang sa antifungals applicable yung like dissolves like, even sa tagyawat, even sa pimple. Para may idea kayo ha, hindi naman natin sinasabi. Nakikinig pa ba kayo? Ha? Okay, hindi naman natin sinasabi na mali yung regimen halimbawa sa paghihilamos pag facial wash agad. Kasi halimbawa kapag natapos ka kasing halimbawa maghapon, galing ka sa labas, syempre punong-puno ng sebum yung mukha mo. May chance na magkatagyawat ka talaga. So ang tendency nun, kapag diretso ka naghilamos, pag diretso ka naghilamos ng tubig, ang tubig ay hydrophilic itself, tapos yung sebum mo ay lipophilic. So the water does not wipe out all the germs, the bacteria and so on sa mukha kasi hindi sila soluble, miscible. Kaya usually ang ginagawa doon is to be able to remove all at first, you must use wax-based cleanser. So gagamit ka ng mga parang kandila siya na talagang oil muna bago ka maghilamos ng tubig para sabay aalis ang sebum tsaka yung wax. Like dissolves like yon. Kasi mas mataas ang chance ng acne formation for example or accumulation ng bacteria kapag diretso ka ng hilamos ng tubig. Okay? Nagets ba? Ayun. Gets? O baka magamit nyo siya for future purposes. Okay? Next, punta na tayo. Ito na yung med-org proper. So second group of agents that we will be discussing are the antifungal antibiotics. Sa module 8 sa antibacterial agents, i-discuss ko ang definition ng antibiotics. Pero para may idea kayo, pag sinabi nating antibiotics, ito yung mga drugs na galing sa microorganisms. Ito yung mga drugs na galing sa microorganisms, kaya antibiotics that are used to kill microbes. Parang ganyan. So meron tayong dalawang specific examples ng antifungal antibiotics. Number one are the polygins, and then second we have griseofulvin. Nagkamali ata ako ng spelling ng polygin. Ito yung tamang spelling ng polygin. So proceed tayo sa unang grupo, we have polygins. Ready na ba sa polygin, guys? Start tayo sa polygin. Good. So first, antifungal antibiotic that we have are the polygins. Ang reason why polygins are termed as such, that's because of their chemistry. So later, i-connect natin yung pangalan sa kanilang chemistry or chemical properties. First, polygins are agents that were isolated from the soil bacteria, particularly in the genera Streptomyces. So that's why yung mga specific examples natin, makikita nyo ang bacterial source ng mga polygins. So let's proceed on the chemical point of view on polygins. Ang reason kaya sila tinawag na polygins because there are multiple carbon-to-carbon double bonds that can be seen in the structure of polygins. Again, ang mga polygins, these are the ones containing multiple carbon-to-carbon double bonds when you check their structure. This is characterized by having conjugated double bond between two carbon atoms that are placed in a large macrocyclic lactone ring. Na-mention ko na before ang lactone. Ang lactone ay isang enclosed structure din that is composed of what functional group? Anong may functional group sa lactone? Ito ay cyclic. Anong tawag sa kanya? Cyclic. Come again. Cyclic. Sige, go. Cyclic. Cyclic ano siya? Hindi pa kayo nag-aaral Hindi pa kayo nag-aaral. Sa Module 4 na-discuss natin ito. Mahirap ang exam. Ako na nagsasabi, mahirap ang exam. Kaya paghandaan nyo siya. So, ang lactone ay isang cyclic ester. Cyclic ester siya. So, pag chinek nyo ang structure ng lactone, ring structure siya na may makikita kayong ester functional group. Now, meron tayong tatlong examples ng polygine antifungal. Number one, we have natamycin or natamycin. Also, we have amphotericin B. And lastly, we have nystatin. Later, I will go back to these numbers. Iko-connect ko siya sa discussion ko later. So let's have a sample structure of a polygine antifungal. This is in the case of nystatin structure. Pwede na nating i-discuss ang structure ng nystatin. Sorry. Wait lang. Na-exit ko, sorry. Share screen ako ulit, wait lang. Ayan. So punta tayo ngayon sa structure ng mga polygins. Guys, lahat ng polygins ay may similar structure na double bonds at also may lactone ring na malaki, macrocyclic lactone ring. So let's discuss the structure of nystatin. Number one, bakit siya polygine? Kasi nga, marami tayong conjugated double bonds. Ang dami, makikita nyo siya dyan. And also, makikita natin na may malaking ring structure. Starting from here, nakapaikot yung structure forming a ring 1. And then, makikita natin sa ring structure niya na lactone siya. Bakit lactone? Anong sabi natin? Ang lactone ay cyclic ester. So that means ang ester ay may formula na RCOOR, hindi ba? RCOOR. So we have here the R group, the carbonyl carbon, oxygen, and then O, R, yung natitira. Kaya RCOR siya. That is the reason why lactone, may lactone ring structure ang polyenes. Pwede natin continue? Ha? Pwede continue? Okay. Now, ano yung meant ng yung mga member atoms indicated in this slide? Ibig sabihin ng 26, 38, yung lactone ring ng natamycin and amphotericin B and also nystatin, 26 and 38 atoms respectively. So pag chinek nyo, pag binilang nyo halimbawa kay nystatin, from the carbonyl carbon up until pag inikot mo siya hanggang sa R group here, again, from the carbonyl carbon hanggang sa pag-ikot mo, there are 38 atoms that can be found. In the case of amphotericin B, we also have 38 and natamycin 26, 26 members. So yun yung reason kaya tinawag silang polyenes. So moving on, i-analyze natin ang structure ng polyenes deeper, ng mas malalim. You can see that in the structure of polyenes, we have two major regions na ma-observe. So number one, meron tayong hydrophilic regions. Again, sa polyene structure, we can see hydrophilic regions. Makikita natin ang hydrophilic regions because of functional groups, alcohol, ay because of alcohol functional group. Ang alcohol ay merong formula na ROH, di ba? ROH. May nakikita ba kayo sa structure ng nystatin, for example, na ROH? Meron ba? Yes or no? Meron. Ang dami, hindi ba? Making this region hydrophilic. So for instance, mag-highlight tayo ng ilan. So halimbawa, ito, and so on. Kung ano pa yung nakikita nyo na ROH. So that's the first one, hydrophilic siya. Second, again, continue natin. Number two, because of the presence of carboxyl group, ay carboxyl group or COOH. Meron ba sa structure ng nystatin na carboxylic group? Meron ba? Yes, okay, nice. So meron, we have the carboxyl group that can be found here. So yun yung mga hydrophilic portions, alcohol and carboxyl group. Actually, meron pang isa. You can also observe that in the structure of, so number one and then number two, you can also observe that in the structure of polyene, meron tayo makikitang sugar, a sugar structure or moiety. And that sugar is found here. So ito naman yung sugar portion niya. So ang sugar portion ng polyene, such as in the case of nystatin, is called mycosamine. Again, ang tawag dito ay mycosamine. Because of the structure of mycosamine, hydrophilic siya. Kasi ang sugar ay polyhydroxy rin, polyhydroxy. So mycosamine yan. Type done if you're finished copying so that I can continue. Done? Okay, good. So focus tayo everybody sa mycosamine. Mycosamine is said to be glycosidically linked. Glycosidically linked with the lactone ring of polyene. Again, mycosamine is said to be glycosidically linked or kadikit siya doon sa lactone ring structure. How can you tell if a sugar is glycosidically linked? Anong meaning ng glycosidically linked? It is based on the glycoside structure. Ay glycoside structure. If you are familiar with glycoside, ang glycoside ay tinatawag na sugar ether. Again, tinatawag ito na sugar ether. So with this being said, sugar ether means na ang structure ng glycoside, ether, ay ROR. Again, it is ROR. I repeat that glycoside is a sugar ether which has a formula of ROR wherein Yung isang R, it represents the sugar. Okay? The first R represents the sugar, and then yung isa naman ay yung non-sugar portion. Ay yung non-sugar portion. So yan yung glycoside, sugar ether. Gets ba ang glycoside structure? Yes or no? Gets? Okay. So everyone, i-apply natin ang structure ng glycoside dito sa mycosamine. Sabi sa slide, mycosamine is glycosidically linked with the non-sugar or with the lactone ring structure. So it's pretty obvious. We have the sugar, mycosamine. So balikan natin ang structure ng polyene. We have here the sugar portion, mycosamine, plus the lactone ring structure, and they are connected with oxygen, making this an ether. Kaya glycosidically bonded yung mycosamine sa lactone ring. Overall, do you get that? Naintindihan nyo? Ha? Naintindihan nyo ba siya glycoside? Ha? O sige, check natin ha kung naintindihan. If I will ask you, makinig ha, you answer what is being asked. In the structure of polyene, in the structure of niacin for example, which is the glycone portion? Pag sinabing glycone portion, sugar portion, what's the answer? What is the sugar portion of polyene structure? Anong tawag? Anong tawag sa glycone or sugar portion? Mycosamine. Kasi ito yung sugar, di ba? Mycosamine. Very good. Now, ano yung aglycone portion in general? Anong tawag natin sa non-sugar moiety nung structure ng polyene? Yun ay made up of lactone. Made up of lactone. Anong functional group kapag glycoside? Anong functional group pag glycoside? Ether. Okay, that's right. Nice. So overall, tapos na tayo sa hydrophilic portion. So recall that in the hydrophilic portion, we have the alcohol, we have the alcohol group, we have the carboxyl group, and the mycosamine or sugar glycosidically linked with the lactone ring. Next, second. So tapos na tayo sa hydrophilic. Nakakasunod ba? Following? Pwede na tayo sa next one? Okay, good. Question. Do you think in the structure of polyene, meron bang lipophilic portion dito if you will check the structure? Yes, kaya ang second region natin is the lipophilic. Okay, again, we have the lipophilic region. Obviously, ang lipophilic region dito is yung mga hydrocarbons, lalong-lalo na yung mga carbon-to-carbon double bonds. So makikita natin siya, i-highlight natin ng color blue for example. So ito yung kanyang lipophilic portion. Again, this is said to be the lipophilic portion. So mag-focus tayo ngayon sa lipophilic portion because of carbon-to-carbon bonds or hydrocarbon. So ano yung importance ng lipophilic region ng polyene? Number one, this is responsible for the antifungal activity of polyenes. So ito yung important sa antifungal activity niya, ay antifungal activity. Bakit? Kasi ang target ng polyene ay cell membrane. Ang target ng polyene ay cell membrane. Important ba ang lipophilicity sa permeability ng gamot sa cell membrane? Yes. Kaya this is essential sa antifungal effect niya. Are you learning so far? Ha? Okay, so continue natin. So with the lipophilic region of nystatin for example, at related ito sa antifungal activity niya, meron tayong important note na dapat malaman about the number of double bonds. And that is, the higher the number of double bonds, again, the higher the number of double bonds, the greater the antifungal effect. Again, the higher the number of double bonds, the greater the antifungal effect. At pag higher ang double bonds at antifungal effect, based on our reference books, the lesser, the lesser the toxicity. The lesser the toxicity. So the greater the double bond, the number of double bonds, the greater the antifungal effect, the less toxic the drug is. Question, so makinig guys, question, bakit kaya? Bakit kaya less toxic sa mammals sa mammals or sa atin, sa mga tao, sa mga animals? So bakit siya less toxic? Because of, based on our reference book also, that is because kapag mas mataas ang number of double bonds, mas mataas ang chance na matatarget ng gamot or ng polyim ang ergosterol rather than cholesterol. Important ba na ang matarget ay ergosterol than cholesterol para maging selectively toxic siya? Yes, okay, very good. So that's why, pag chinek nyo ang number of double bonds, you can actually tell kung sino ang pinaka-toxic sa kanila, sino ang least toxic when you check the structure mamaya. So i-explain or i-apply natin later yung mga specific examples. But so far, did you get the point sa lipophilic and yung antifungal activity? Very good. So yan po ang chemistry ng polyeins. So recap tayo sa polyeins, may hydrophilic, may lipophilic. Tandaan nyo ang mga functional groups dyan. Okay, tandaan natin. So next, moving on tayo, let's have the mechanism of action of polyein antifungals. Number 1 na dapat nyong tandaan, ang polyein, as I've said, tinatarget ang cell membrane. Tinatarget ang cell membrane. Polyeins act as false membrane components and they bind to ergosterol. Ergosterol, which is the essential sterol present in the fungal cell membrane. So what they do is like this. Ang polyeins, because of their lipophilic region, para silang barena wherein nabubutas nila ang cell membrane because of their lipophilicity, pupunta sila sa cell membrane and then papasok sila doon. So para silang barena, nakakapasok sila, causing the following. Number 1, disruption of the membrane. Remember, the cell membrane is important for exchange of compounds. So kapag sira yon, hindi na regulated, mamamatay talaga yung fungi. And also cessation of enzymic action. Important ba ang sterol sa enzyme action? Yes, nabanggit or na-discuss ko siya kanina. And then, because of excessive potassium ion leakage, nagkakaroon ng loss of cellular components. Okay? Or nagre-result din siya sa membrane disruption. So basically, yan ang mechanism of action ng polyeins. So going back to polyeins or moving on to polyeins, there are 3 examples, right? These are actually highly potent. They are highly potent and they have broad spectrum of action. Guys, yung tatlong polyeins, kahit sinabi natin na mas mataas ang double bond, less toxic. Toxic pa din siya essentially. Delikado silang lahat. Pero kung i-weigh mo kung sino ang pinaka-toxic sa least toxic, sa double bonds kayo mag-base sa number of double bonds. These agents are said to be effective against several fungal microorganisms like yeasts, molds, and also dermatophytes. Based on this info, ano yung ating marirealize din? Ang polyeins, pwede siyang may mga examples na systemically administered, lalo na yung mga nakapasok na mga fungi sa katawan natin, or may mga topically administered. And of course, reminder lang, polyeins are not active against other microorganisms. So focus lang sila sa fungi. So for the applications of polyeins, sabi natin, they are powerful agents. That's why they can be used for systemic fungal infections. However, in general, these drugs are highly toxic. Highly toxic sila. And they have low water solubility despite of the presence of hydrophilic region. They are still lipophilic. And then they have poor chemical stability, kaya limited na lang ang applications ng polyeins. Amongst the three examples, amphotericin B is the only agent that is useful for systemic infection. Question, why? Bakit? Number one, may kinalaman ito sa structure ng amphotericin B. Mamaya mawi-witness natin or mare-reveal natin, but amongst the 3 commercially available polyenes, siya ang may highest number of double bonds. Siya yung may highest number of double bonds. Question, pag merong pinakamaraming double bonds, ibig sabihin ba nito relatively safer siya compared sa iba? Yes or no? Yes. Kaya, relatively relatively. Pag sinabing relatively, pag kinompare mo sa iba, safest siya, safest. Pero toxic pa rin siya kung i-compare mo sa ibang mga grupo. Kumbaga, that's why this is the only useful polyene antifungal for systemic infection. Pwede siyang i-administer for systemic effect. Yung iba kasi sobrang toxic kaya limited na lang. Halimbawa, sa topical administration or local administration. Okay? So next, proceed na tayo everyone sa mga specific examples ng polyenes. O recall tayo, ilang examples ng polyenes do we have? Tatlo. Okay, tatlo. So discuss natin ang first example, that is amphotericin B. Question, bakit siya amphotericin B? Guys, nung dinidiscover ang amphotericin drug, meron tayong dalawang variants na tinest. We have amphotericin A and amphotericin B. The one that is found to be effective antifungal, the one that had the greatest activity, is the amphotericin B. Kaya amphotericin B yung pangalan niya. And ang reason kaya siya tinawag na amphotericin kasi siya ay isang amphoteric substance. Kasi siya ay isang amphoteric substance. Later, when we witness the structure of amphotericin, I'll explain ba't siya amphoteric. Doon ko na siya i-discuss. So first, amphotericin B was isolated from Streptomyces nodosus. Siguro na-encounter nyo na to sa microbiology. And as I've said, compound B is said to be more active than compound A. And it was also mentioned that it acts as a false membrane component, thus entering the cell membrane, the ergosterol membrane of fungi, causing disruption. Now, although na-discuss natin na siya yung may greatest antifungal effect or mas selectively toxic, still, it can affect cholesterol. Kaya essentially, amphotericin B is toxic by itself. Pero kung i-compare nga natin siya sa nystatin or sa natamycin, siya pa rin ang pinaka-safe. Kasi nga, siya yung richest in double bond. Okay? Siya yung richest sa number of double bonds. And nabanggit natin amphoteric substance siya. Later, i-discuss ko nga yung structure ng amphotericin B. And this agent is being used for life-threatening fungal infection that is intended for systemic administration. Number one, chemically incompatible ang amphotericin, mahirap i-prepare at i-store ang amphotericin. So to be able to enhance the stability of amphotericin, this is being stabilized with sodium deoxycholate. Sodium deoxycholate. So this is being stabilized with sodium deoxycholate. Next, based on scientific evidences as well, ang amphotericin B, it does not enter the triple B or the blood-brain barrier. Ano yung implication kapag hindi nakakapasok ang drug like amphotericin B through the blood-brain barrier? Hindi siya nakakapasok saan? Hindi siya nakakapasok sa brain. It cannot enter the brain. So, yun yung na-discover about amphotericin. It's kind of weird kasi ang amphotericin ay lipophilic. Di ba ang idea natin pag lipophilic, dapat permeable sa blood-brain barrier. But again, based on researches, amphotericin B cannot enter through the blood-brain barrier. Hindi siya makakarating sa utak. Question, anong implication nito? Nakikinig pa ba kayo? Ha? Are you still listening? Okay, good. So ang amphotericin B, it does not enter the brain. Question, what's the implication? Mind you that there are fungal infections affecting the brain. So kapag utak ang affected sa isang fungal infection, one of your considerations in choosing an antifungal, dapat makakarating sa utak. So ang problem, ang limitation kay amphotericin, kapag in-administer mo intravenously, for example, pag sa ugat mo siya nilagay, wala, hindi niya matitreat ang brain infection or fungal infection in the brain. That's why if you intend to use amphotericin in the treatment of brain or CNS fungal infection, you must administer it intrathecally, ay intrathecal. So kapag intrathecal, saan nilalagay? Saan nilalagay? Sa spinal fluid siya ilalagay. Okay? Sa spinal fluid. Para pag sa spinal fluid, diretso na sa utak. So ituturok yun sa likod, okay? Sa spinal column na ng pasyente. So very important ang route of administration. Guys, na-gets ba ako? Okay, good. Next, the major limitation. Tapusin lang natin yung polyin bago tayo mag-health break. So for amphotericin B, yes, it's relatively the safest amongst the polyins, pero delikado pa rin talaga siya. The major toxic effect that can be brought about by amphotericin B is nephrotoxicity, meaning kidneys are being affected. Nearly 80% of the cases ng adverse effects ng amphotericin attributed dito sa kidney damage effect. And also, if administered parenterally, like intravenous for example, it can result to thrombophlebitis. That's why it is recommended to never administer amphotericin B intramuscular. So limited lang siya if parenteral, intravenous, or intrathecal routes, depending on the case. So these are the pharmacological properties of amphotericin B. So with that, i-discuss natin ang kanyang chemistry. O dito tayo sa chemistry ng amphotericin B. Question, when you check the structure of amphotericin, halimbawa, nagpa-exam ako, nagpa-activity ako. Halimbawa, may question ako doon. Given this structure, is this a polyin or not? Or halimbawa, true or false? Amphotericin B is a polyin antifungal. True or false? Based on the structure that you can see. True. Bakit? Ano ang inyong checklist para polyin siya? Number one, dapat may malaking ano tawag doon? Lactone. Okay, dapat may malaking lactone ring. Very good. Pero dapat yung lactone ring, meron siyang paired conjugated double bonds. So kaya ano siya? Polyin. Not to mention na may glycoside siya, ay na may glycoside structure siya. So check. Pwede kasi ang exam natin or activity, puro structure lang pakita ko, tas true or false. This is a polyin based on ganyan, ganito, ganyan. So dapat alam nyo ang criteria para malaman ko anong grupo siya. Hindi lang siya kabisaduhan na amphotericin B is a polyin. No. Structure ang papakita natin. Kaya you have to be familiarized with the structure. So going back, let's check. Wala naman kasing problema sa ibang portions eh. Nagmamatter siya sa portion ng lipophilic region. Pakibilang ilang double bonds meron sa lipophilic region. And then tell me the answer through chat. Ilan? Very good. 7. Okay, 7. So that's why ang tawag natin kay amphotericin B, siya ay isang polyin na heptaine. Ayun, na may heptaine group or heptaine portion. Heptaine meaning there are 7 conjugated double bonds. Making it pinakamarami na double bonds kasi halos lahat sa baba meron ng double bonds. Okay? So that's the first information about amphotericin. Next, tinawag siyang amphotericin kasi based on our reference book, siya nga ay isang amphoteric compound. Pag sinabing amphoteric, anong ibig sabihin ng amphoteric? So pag sinabing amphoteric, that means yung gamot, it can act as an acid and also it can act as a base. Okay, very good. So tama yung mga answers nyo guys. So ang amphoteric compound like amphotericin B, it can act as an acid or a base. Why? Bakit siya pwede mag-act as an acid or a base? Kasi there are functional groups ng amphotericin B that can either donate or accept proton. First, those that can or the functional group that donates proton is the carboxyl group. So this is the one that donates the proton, while the one that accepts is the primary amino group found in the mycosamine sugar. So this is the one naman that accepts proton. So based on this principle, Sino ang acidic functional group? Is it the carboxyl or the amino? Very good. So that is that is the carboxyl group. Okay, that is the carboxyl group. And then the amino group represents the base. Kasi nga acceptor siya, okay? Proton acceptor. So yan yung reason kung bakit amphotericin B ang tawag sa kanya. So unti-unti nyong na-realize kahit papaano na ang pangalan pala ng grupo ng mga drugs o kaya yung specific name sila naka-base din minsan sa chemistry, sa structure nila. So taken all together, that's amphotericin B. Naintindihan ang amphotericin B? Pwede na tayo sa nystatin. Sige, punta na tayo kay nystatin. Ulitin ko ha, tapusin natin ang polyenes bago mag-health break. Second example is nystatin. Nystatin is isolated naman from Streptomyces norsei. And if you will check later the structure of nystatin, aside from the glycone portion, pag sinabing glycone, yung sugar ha, yung sugar portion, yung mycosamine, bukod doon, meron siyang aglycone portion, yung malaking lactone ring niya, ang tawag natin doon ay nystatinolide. Ay, nystatinolide. Hindi lahat sinuplayan ng aglycone names sa book natin, pero si nystatin meron siya. That is nystatinolide. Now, based on this slide, we can tell that nystatin is only used as a topically administered antifungal agent. So meron tayong reason kung bakit siya ginagamit as a topical antifungal only, limited sa dermatophytosis. Why? Kasi nystatin is much more toxic than amphotericin B, limiting its application for systemic purpose. Nagets ba yung sinabi ko? Topical siya kasi toxic siya. So next, topical agent, that's why it can be used for cutaneous candidiasis. So ibig sabihin, sa balat din yun. Now, if you will check the last bullet, nakalagay, it can be used in the treatment of local and gastrointestinal infections. Sir, akala po ba namin topically administered lang ang nystatin? So explain natin yung last bullet for you to understand. Ang nystatin, guys, ang nystatin, pwede siyang i-take by mouth, pwede siyang i-take by mouth, pero ang effect kasi kapag by mouth administered, it is not absorbed systemically. Again, kapag siya ay in-administer by mouth, it is not absorbed systemically. What do we mean by that? Again, anong ibig sabihin natin doon? Pag tinake mo siya by mouth, hindi siya kayang i-absorb ng bituka, so it does not enter the blood. Kaya hindi rin siya madidistribute sa iba't ibang parts ng katawan. With that being mentioned, ang ating realization is pag ininom mo siya by mouth, nakakoncentrate lang ang nystatin's action sa GI tract. Kaya for gastrointestinal fungal infection, pwede ang nystatin. Kasi technically, localized pa rin siya. Localized pa rin siya. Gets? Or ulitin natin. Nagets nyo ba? Nagets? Okay, sige. Good. So that's the reason. Pero pag parenteral, pag ituturok mo siya, delikado siya. Okay? Napaka-toxic niya compared sa amphotericin B. So punta tayo sa structure ng nystatin. Actually, pinakita na natin ito kanina. Unang tanong, ilang double bonds meron kay nystatin? 6. Less or more compared to ampho? Less. Less or more toxic than ampho? More. Na-connect ba yung double bonds, guys? Okay. So let's observe. Actually, sabi ko nga, sa lipophilic region lang sila halos nagkakaiba. So let's analyze the lipophilic region of nystatin. Since there are six double bonds present, ang tawag naman natin dito ay hexane. Hexane naman ang tawag natin. Ano yung characteristic nung hexane hexane structure found in nystatin. Hindi siya continuous as compared to amphotericin B kasi ang amphotericin B sunod-sunod yung double bonds. In the case of nystatin, may putol, discontinuous siya. So this is divided into two double bonds and then four double bonds, right? So meron tayong two double bonds and four double bonds. That's why in other references, ang structure ng nystatin is described as having a diene, and a tetraene. Having a diene and also tetraene separated by methylene groups. Separated by methylene groups. Question, ulitin natin ha, diene at tetraene. Di kasi 1, 2, dalawang double bonds, 1, 2, diene. And then we have tetraene, 1, 2, 3, and 4. Now, ang nagbe-bridge or the ones that separate diene from tetraene, methylene daw, methylene. Question, ilang methylene group or groups ang makikita sa partition ng diene at tetraene? Ilan yan? Very good, dalawa. Dalawang methylene. So meron tayong isa, meron tayong dalawa. Dalawang methylene groups. Gets? Ha? Gets? Okay. Next, natamycin. O, punta tayo sa natamycin. So for natamycin, double bond ulit. Ilan ang double bond or bond sa natamycin? Bilangin. Palinawan ng mata, ilan? Yes, 4. Huwag nyo nang bilangan nyo nasa taas. We must focus more on the lipophilic region. Okay, sa baba. So there are 4. Kaya sa lipophilic region, ano ang tawag natin sa double bond? Tetraene naman. Tetraene sa natamycin. Okay? Natamycin is highly toxic kasi 4 lang ang meron sa kanya. So this was isolated from Streptomyces natalensis. So that's the structure of natamycin. So regarding the mechanism of action of natamycin, ito yung distinct sa kanya. Same MOA, same mechanism dun sa diniscuss ko kanina, but ang point dito is yung kanyang dose o yung concentration being administered. Take note, sa kahit anong concentration, whether high or low drug concentration, ang actions ng natamycin dalawa, fungistatic and fungicidal. Fungistatic and cidal, whether high or low concentration. Fungistatic siya because it promotes potassium ion leakage from the cell membrane. Again, potassium ion leakage from the cell membrane. Cidal naman siya because it promotes cell lysis, fungal cell lysis. So static, fungistatic because of potassium ion leakage, and then cell lysis pag cidal. Again, whether high or low concentration, same actions. Both yan ginagawa niya. Question, anong difference nito sa amphotericin B and also nystatin? Anong difference? Ang amphotericin B kasi at ang nystatin, dose-dependent yung action niya. Pag sinabing dose-dependent, iba ang effect pag low, iba ang effect pag high concentration. Kapag low, again, kung nakikinig, kapag low concentration, static usually ang effect nila. Ay static. And then pag high concentration, they become cidal. So that's the difference in terms of the actions held by amphotericin B and nystatin compared to natamycin. Type done if you're finished copying. Done? Very good. So anong takeaway natin sa sinabi ko? Based on this input, ang natamycin ba ang mako-consider talaga natin pinaka-toxic based on this action? Yes or no? Siya ba yung mako-consider na pinaka-toxic sa tatlo? Based sa action? Yes. Based sa action na hindi sa... Wag mo na kayong tumingin sa chemistry, sa action. Yes. Kasi, mababa man o mataas, parehas niyang ginagawa. Unlike nung dalawang agents kanina, it depends on the dose. So that talks about safety din. So maiko-connect natin siya sa chemistry naman, kasi sa tatlong agents, sino ang pinakakonte ang double bonds? Sino ang pinakakonte? Si natamycin kasi may 4 siyang double bonds. So overall guys, we are finished with polyene antifungals. So pag chinek nyo yung outline natin sa antifungal antibiotics, tapos na tayo sa polyenes. O review tayo sa polyenes. Again, review tayo sa polyenes. Sa polyenes, diniscuss natin ang kanilang chemistry, yung mga regions na discuss natin, and the relevance of the regions sa kanilang antifungal activity. And then, we were able to discuss the number of atoms present in the lactone ring. So, home assignment nyo na lang yung pagbilang ng mga atoms sa lactone ring. Pero magmamatch naman siya pag binilang nyo. And then, we discussed the mechanism of action, the specific examples, and the structures of the examples. So please, pag nag-aral kayo, please do recognize the differences and similarities ng mga structures ng examples. Done with polyenes. Guys, naiintindihan ang polyenes? Okay, so it's now recording. After we discuss polyenes as the first group of antifungal antibiotics, proceed tayo sa pangalawa. This is a sole drug. So wala siyang specific members, nag-iisa lang siya, or classes, nag-iisa lang siya. That is griseofulvin. Griseofulvin was isolated from the microorganism Penicillium griseofulvum, kaya griseofulvin ang pangalan niya. And this is used in the treatment of refractory ringworm infections. Pag sinabing refractory, that means hindi na siya quote and unquote treatable using topical antifungals. Hindi na effective yung mga topical antifungals. Ito na yung ginagamit, griseofulvin. Caused by dermatophytes like trichophyton, microsporum, and epidermophyton, na-discuss ko siya. Kaya ginagamit ang griseofulvin sa mga dermatophytosis or tinea na quote and unquote refractory cases or untreatable cases. Now, ang structure ng griseofulvin is like this. So para madali nyong ma-recognize ang structure niya, rare structure yung ganito. So very madalang yung mga agents having this structure. And based on our reference book, ang tawag natin dito ay spirocompound. So when you encounter the term spirocompound, you can link it automatically with griseofulvin's structure. Okay? This is characterized by having a spirocompound or spirostructure, which is quite rare. Now, ang mechanism of action ng griseofulvin, isa siyang mitotic spindle poison. In other words, this agent targets or blocks mitosis. Again, this drug targets mitotic process or cellular division. Important ba ang cell division for fungal growth and also fungal multiplication? Yes, para dumami siya. Now, kapag binlock natin ang mitosis, mapipigilan natin ang pagdami ng fungal cells pero we do not actually kill the cell. Kaya, fungistatic lang ang griseofulvin. And just like other antifungals, this agent is not effective against bacteria kasi hindi siya antibacterial. And something unique about griseofulvin, it is not effective to a specific type of tinea infection caused by Pityrosporum orbiculare. Okay? And ang problem kay griseofulvin, by the way, ang route of admin ni griseofulvin by mouth, hindi siya topical. Pero anong sabi natin? Ginagamit siya for topical infection. So, kinda nalilito kayo, nako-confuse kayo, bakit sir by mouth pero topical infection ang tinitreat niya? So, i-explain ko siya right now. As I've said, ang griseofulvin, ang tina-target niya ay refractory cases. So, meaning to say, kapag gumagamit kasi ng topical antifungal sa mga refractory dermatophytosis, superficial lang ang natatarget nung gamot, nung antifungal drug. Yung deeper layers ng precursor cells ng keratin, for example, yung mga cells na gumagawa ng keratin, ang problem pag refractory, yun na yung affected. And that cannot be reached by topical antifungals. So ang ating means, ang ating paraan to be able to reach deeper layers or yung mga precursor cells that are meant to become keratin, kailangan systemic administration or by mouth. Like in the case of griseofulvin, once taken by mouth at nakapasok sa ating bloodstream, it will reach the capillary beds doon sa precursor cells that produce keratin. Kaya tendency, kapag nag-keratinize yung superficial layers at umappear na yung panibagong keratin, treated na with griseofulvin yun. So wala nang fungi doon, patay na sila, or fungistatic effect na doon sa deeper layers. So kumbaga, matagal ang effect ng griseofulvin kasi aantayin mo na mag-keratinize yung superficial layers, and when the time comes na mag-produce ng panibagong keratin, treated na with griseofulvin yun. So that's the rationale. However, the problem with griseofulvin, it has a poor oral bioavailability. That's why it is recommended to take it with a high-fat meal. Okay? That's the limitation of using griseofulvin. So for the example tinea infections that can be treated using griseofulvin na hindi na nga responsive sa topical antifungals, we have the following tinea infections. As I've mentioned earlier, it is based on the location, and 100% certain ako na na-encounter nyo na yung mga terms sa to. So, kayo nang bahala mag-review ng mga locations sa to kasi it was already discussed in microbiology. So, we have tinea capitis, cap, so ulo, so hair yon, and then scalp, pedis, pedal, so paa, then manuum, hands, parang manual hands, then cruris or jock itch sa singit, and then ungium sa fingernails, sa ating kuko, sa ating kuko. So yan yung mga applications ng griseofulvin. Pero ulitin ko, hindi siya topical administered or topically administered. Gets? Nagets nyo? Nice. So done with antibiotic or antifungal antibiotics, which include griseofulvin and polyenes. O third group na tayo, bale, out of 8. So number 3 are the allylamines and related compounds. Related compounds, mamaya may encounter nyo kung ano yung related compounds to allylamines. And also, based on chemistry, I'll explain what allylamine means. Regarding allylamines as antifungals, these agents interfere with the early step of ergosterol biosynthesis. Na-discuss ba natin ang pathway involving ergosterol production? Yes, na-discuss natin yan. And meron tayong dalawang very important steps that must happen for ergosterol to be produced. One of them is epoxidation of the hydrocarbon squalene. So that is, may epoxidase or mag-undergo siya na epoxidation because of the enzyme squalene epoxidase, which would eventually lead to lanosterol production. So that specific pathway is being targeted by allylamines. In other words, allylamines are inhibitors of squalene epoxidase enzyme. These are the agents that can block squalene epoxidase. So meron tayong dalawang effects na pwedeng mangyari if squalene epoxidase is blocked. So what are those? So para maintindihan, balikan natin yung pathway involving squalene epoxidase. Remember for the nth time that this is the enzyme needed for the formation of squalene epoxide and eventually lanosterol as the first sterol produced. So kapag na-block ng allylamines ang squalene epoxidase, dalawa nga yung effects na pwede mangyari leading to cell membrane damage or cell membrane destruction. Number 1 is effects sa squalene itself. Question, ano yung pwede mangyari sa levels ng squalene if allylamines are used? Tataas ba ang squalene levels or bababa ang squalene levels? Tataas or bababa? Tignan mabuti yung pathway. Ang allylamines ay binablock ang squalene epoxidase. Pinipigilan niya yung paglipat o pag-convert ng squalene to epoxide. So pag pinipigilan, nare-retain as a squalene ba ang squalene? Yes, di ba? So question again, Taas or baba? That is tataas. Very good. So that causes accumulation of squalene levels in the fungal cell membrane. Squalene is hydrocarbon that is toxic when accumulated, leading to cell membrane damage. So yan yung first effect, accumulation of squalene. Next, another effect. Meron din siyang effect sa levels ng lanosterol. Ay meron din siyang effect sa levels ng lanosterol. Oh, based on this pathway, what happens to lanosterol produced? High or low? Very good. Bababa naman ang lanosterol levels. Ang lanosterol ba ay important for ergosterol production? Yes. So in short, pag bumaba ang lanosterol levels, ang sterol sa cell membrane ng fungal cell mababa. Question, important ba ang sterol na component ng cell membrane? Yes. So mamamatay talaga yung fungi or fungal cell. That's why ang mga allylamines ay fungitoxic talaga sila. Ay fungitoxic or fungicidal sila. So they can actually target the cell membrane. Nagets ang mechanism of action ng allylamines? Ha? Very good. Balik tayo sa previous slide. One distinct property also of allylamines is this one. Cholesterol biosynthesis is not affected. Question, what's your conclusion? What's your inference? Are allylamines safer to use or not? Very good. They are selectively toxic kasi they only target ergosterol synthesis. So very important nga na inintroduce natin ang cholesterol at ergosterol as biochemical targets. Moving on, the following are the examples of allylamines. Number one, we have naphthephin. Second is terbinafine. Also, we have butenafine and tolnaftate. Regarding naphthephin, this is the prototype allylamine because it is the first one discovered. However, limited siya for topical administration. So this is limited for topical administration. Question, bakit? Ay why? That is because ang naphthephin, if administered by mouth, it undergoes extensive first pass effect. Okay? It undergoes extensive first pass effect. Alam na ba ang first pass effect sa module 1? Hmm? Yes, that's why it's limited for topical administration. Very good. Also, we have terbinafine. Which is considered as more potent than naphthephin. And then finally, we have butenafine and tolnaftate. With regards to butenafine and tolnaftate, chemically speaking, based on the structure, they are not allylamine. But they are both squalene epoxidase inhibitors. Kaya ang title natin dito sa PowerPoint kanina ay Squalene and Related Compounds. Okay? Squalene and Related Compounds. Na-discuss natin yon earlier. Okay? So ngayon, ipaliwanag natin bakit allylamine ang tawag based on the structure at bakit merong hindi allylamine in terms of structure. So with that, let's have this sample structures of allylamines. So first stop, ano ba ang ibig sabihin ng allylamine? By the way, pwede na ako mag-discuss ng chemistry nila. Pwede na? Nice. So discuss natin. Pag mag-aaral kayo at may na-encounter kayong bagong term, dapat ang una nyong question sa title, bakit yun yung pangalan? So ang usually ako ng estudyante, pa nag-aaral ako, bine-breakdown ko yung term, lalo na sa mga compound names. So just like in this case, allylamine. Basically, pag sinabi nating amine, amino functional group, RNH2. So meron siyang amino functional group. Okay? Now, ano naman ang ibig sabihin ng allyl? May kinalaman ito sa allylic carbon. Again, may kinalaman ito sa allylic carbon. So ano ang definition natin ng isang allylic carbon? Ang allylic carbon, this is a carbon, medyo confusing sa unang basa ha, pero you will eventually understand this for sure. So allylic carbon is a carbon bonded to another carbon, which is in turn double bonded to another carbon. Okay, ulitin natin. Allylic carbon, kopyahin nyo muna bago ko explain, is a carbon bonded to its adjacent carbon, which in turn is double bonded with another carbon. So yun yung ibig sabihin natin ng allylic carbon. Type done if you're finished copying. Okay, good. So for example, we have this given structure. Halimbawa lang this given illustration or carbon-to-carbon bonds. So if this is an alkene or carbon-to-carbon double bond, yung adjacent carbon niya na single bonded lang, allylic ang tawag dito. Ay allylic carbon. Nagets ang allylic carbon? Ha? Very good. So taken all together, pag sinabi nating allyl amines, ibig sabihin, ang allyl carbon or allylic carbon, may katabi siyang amino group. Yung allylic carbon, may katabi siyang amino group. Kaya ang tawag sa kanya, allyl amine. Gets? Yes or no? Gets? Okay. So meron tayong true allyl amines. Pag sinabing true allyl amines, meron silang allylic carbon na bonded sa amine. So we have naphthyphene and terbinafine. Ang clue nyo dito is sa side chain, hanapin nyo ang double bond. So we have the double bond here. Naphthyphene muna tayo guys naphthyphene. The double bond here. So question, yung dinadat ko ba ng red ang allylic carbon? Yes or no? Yes or no? Yes, very good. So this is the allylic carbon. May amino group ba siyang katabi? O yes or no? Yes. Kaya, is this true or false allyl amine? True, very good. Next, terbinafine, true allyl amine o false? Is this an allyl amine? Yes, very good. Next, dito tayo kay butenafine. Is this a real allyl amine or related compound lang siya? Related lang. Kaya nga ang title natin, allyl amines and related compounds. Pero ba't natin siya sinali dito? Kasi ang similarity nila sa true allyl amine, they are both squalene epoxidase inhibitors. Okay, they are both squalene epoxidase inhibitors. Gets? Are you learning, guys? Next, tolnaftate, related or allyl amine? Very good. Okay. So in terms of structure, may idea na kayo ba't allyl amines ang tawag. So pag nag-aral kayo, i-compare nyo siya sa polyene. Ang polyene, ang laki-laki ng structure, di ba? May lactone, may mycosamine, and so on and so forth. Okay? So, study tip, it's your job not to check the difference, yung itsura ng pagkakaiba. Swerte nga kasi online makakapag-kodigo kayo dyan. Pero pag face-to-face, walang tinginan, talagang kakabisaduhin nyo yung itsura. Hindi ko naman papadraw kung face-to-face yan, pero recognition, of course. Okay, so tapos na tayo sa allyl amines. Nakakailang grupo na tayo, everyone? Nakaka-apat na. Ay, apat. Topical, antifungal antibiotics, and then we have allyl amines. Pwede na tayo sa azole, antifungals. Goal ko matapos ang azole. Hopefully matapos ko yung azole today. Yung susunod, bukas na. Start na tayo dito, guys. Yes or no? Siguro pwede na tayo mag-continue. Okay. So next, we have azole antifungals. Later ko i-explain bakit azole ang tawag sa kanya. Of course, related na naman ito sa chemistry ng azole antifungals. Amongst the commercially available antifungal agents, ang azole sila ang largest in terms of class because the number of examples greatest compared sa ibang mga commercially available. These are synthetic antifungal agents. And these are effective for cutaneous fungal infections or dermatophytosis, affecting particularly mucous membrane caused by the three genera nga ng dermatophytes, Tricho, Epidermo, and Microsporum species, genera. So the mechanism of action, ang tinatarget ng azole antifungals, depende sa concentration of course. It can be cidal or static, depende sa concentration. But basically, ang mechanism of action niya may kinalaman din sa ergosterol synthesis. Ergosterol synthesis. Kaya yung pathway involving ergosterol, madidiscuss ulit natin. Kaya nga ko siya inintroduce kanina. Resulting to cell membrane damage and loss of cell components. So in connection to that, i-discuss natin ang MOA ng azole antifungal depending on the concentration. At low concentration, ang tinatarget ng azole antifungals ay yung fungal cell membrane. Again, at low concentration, azole antifungals target the fungal cell membrane, and that can be achieved by inhibiting the enzyme called lanosterol 14-alpha demethylase. Nare-recall ba yung enzyme na to earlier? Yes or no? Very good. So na-discuss natin siya kanina. Kaya ngayon, babalikan natin pero sa baba na tayo ng lanosterol, lanosterol metabolism. So going back with this this pathway, remember that when the first sterol lanosterol is synthesized, sunod-sunod na yung mga events that would lead eventually to the formation of ergosterol, which is the principal sterol component of the fungal cell membrane. Now, essential in this pathway is oxidation of lanosterol. When I say oxidation, particularly at carbon 14, removal of methyl group via the action of 14-alpha demethylase. Anong klaseng cytochrome ang 14-alpha demethylase? CYP? Yes, very good. So that is CYP51. So oxidative enzyme siya. So yan ang responsible enzyme for the oxidation of lanosterol, eventually forming ergosterol. So in connection to the drugs that we are discussing right now, this is being blocked by azole antifungals. So by inhibiting this, mape-prevent natin ang ergosterol production, resulting to cell membrane disruption at low doses or concentration. Now, kapag high dose na siya, kapag high dose, tendency, pati mammalian enzyme na ta-target. So pag pati mammalian enzyme, like animal cells, containing this enzyme ay na-target, toxic na siya. In short, kapag high dose ng azole antifungal, toxic na siya sa tao. Pero pag low dose, usually, fungal cells lang ang tina-target. Kaya related yon sa selective toxicity. Okay? That's why it's related to selective toxicity. Now, let's proceed on the chemistry of azole antifungals. So ngayon, i-discuss natin bakit azole ang tawag sa kanya. Ano ba ang ibig sabihin ng salitang azole? Ang azole ay isang five-membered, this is a five-membered heterocyclic ring, a heterocyclic ring structure containing nitrogen atom. Again, azole is a five-membered heterocyclic ring structure containing nitrogen atom. So that's what we mean by the term azole. Type done if you're finished copying. Good. So that's the definition of azole. So with this information noted, pag nakita nyo ang isang five-membered ring structure, azole na ang tawag doon. Basta may nitrogen siya. And technically, when we talk of azole antifungals, when you check the structure of the examples, you can categorize the specific examples into two groups. Meron tayo mga azoles na dalawa ang nitrogen atoms present. Meron tayong azoles naman na tatlo ang nitrogen atoms present. So for example, in this given figure, given structure, you can tell that this is the azole ring and there are two nitrogen atoms present. And then we have this structure in the right side having three nitrogen atoms. So based on this information, we have two subclasses. Again, we have two subclasses of azole antifungals. Those that contain two nitrogen heterocyclic atoms are called as imidazoles. Again, ang tawag dyan ay imidazoles. So imidazole antifungal kasi imidazole yung dalawa ang nitrogen. And then kapag naman tatlo, ang tawag dito ay triazoles. So we have imidazoles and also we have triazoles. So these are the subclasses of azole antifungals. Did you get these subclasses? Yung imi at triazoles? Good. So these are the subclasses of azole antifungals. Sa succeeding slides natin, ito yung mga specific examples. Number one, we have miconazole, econazole, and so on and so forth. If you will check, the general structure of these agents is this one. Ito yung general formula ng structure nila. You can see that ang 5-membered ring ay dalawa ang nitrogen, kaya overall, these are the examples of anong klaseng azole, imi or tri. Very good. So these are the specific examples of imidazole antifungals. So it's your job already to check the specific structure of the examples. Kailangan pag-aralan niyo yung mga difference sila. O makikita niyo naman yung substitution sa table na to. Okay? Basta ang common sa kanila ay merong imidazole ring. What about this one? For fluconazole, voriconazole, itraconazole, turconazole, and posaconazole, all of them contain what? Triazole. So kaya ito, mga triazole antifungal agents. Again, trabaho nyo na i-check ang individual structures. Kaya pag-aralan nyo yung mga differences ng mga individual structures. So next, let's have the SAR or structure activity relationship of azole antifungals. When we talk of the SAR or structure activity relationship of azole antifungals, ang i-discuss natin dito is paano didikit ang azole, how will azole bind to 14-alpha demethylase o yung CYP51. So didiscuss natin dito yung attraction o yung bonding between the drug itself and the enzyme itself. Recall, for the nth time, ang 14-alpha demethylase ay isang cytochrome. How can you tell if a certain enzyme is a cytochrome? Important component niya ang heme. Naalala nyo ba yung heme before? Okay, kaya konektado lahat ng modules. Natatandaan ba ang heme na merong central ion? Yes. And then, may 4 na coordinated bonds for nitrogen, at mag-focus lang ako sa related sa antifungals at isang coordinated bond nga doon ay para kay oxygen. 'Di ba? Yung isa ay para kay oxygen. So anong ginagawa ng azole antifungals? Azole antifungals, because of the presence of their nitrogen atoms, ito yung reason kung bakit didikit sa heme ang azole antifungals. Particularly for imidazole antifungals, the one that will bind to the heme is nitrogen 3 of imidazole, while for triazole, it's N4 or nitrogen 4. These are the portions of the drugs that will bind to the heme ion, preventing oxidation. So ano yung specific coordinated bond na pupuntahan ng imidazole at triazole sa heme? Ang pupuntahan, nakakasunod ba? Nakakasunod? Pag triazole, nitrogen number, anong number? 3 or 4? Pag imidazole, anong number? 3. Okay. Pupunta nga sa heme. O balikan natin yung structure ng heme. Di ba ang heme may 4 na coordinated bonds for nitrogen and then yung isa for oxygen. Guys, ang pupuntahan ng nitrogen 3 o kaya ng nitrogen 4 yung oxygen. So, dito didikit sa coordinated bond for molecular oxygen yung gamot, whether N3 or N4. In other words, pag bound na yung drug sa isang coordinated bond ng ion, walang lugar for oxygen to bind. There's no area for oxygen to bind. Question, in the catalytic cycle of oxidation, important component ba or ingredient ang oxygen? Yes, important component siya, di ba? In short, pag walang madikitan ang molecular oxygen, may oxidation? Yes or no? Meron o wala? Wala. Kaya mangyayari ba ang demethylation? Yes or no? No. Pag walang demethylation, may ergosterol ka ba? Wala. Antifungal effect. Antifungal effect. Kaya pag chinek nyo ang structure ng anong gamot to? Nakalimutan. Azole antifungal. Kapag chinek nyo ang presented structure dito, ito yung representation ng heme. Ito yung representation ng heme. Pansin nyo, yung isang nitrogen, yung N3 ng imidazole, dumikit doon sa coordinated bond for oxygen. So no oxidation. Guys, nagigets nyo pa ba? Nagigets nyo ba ako? Nice. Okay. Next. Proceed tayo. Again, tatapusin ko ang azole antifungals. So regarding the examples of azole antifungals, these are as follows. So sa structure, nakita nyo na sila kanina. Number one, we have clotrimazole, which is not suitable for systemic infection. Then thioconazole, miconazole, and then ketoconazole. Distinct to ketoconazole is its absorption. Note class that ketoconazole has a good oral bioavailability at low pH environment. Therefore, saan intended na ma-absorb ang ketoconazole? Stomach or small intestine? Stomach. Very good. Sa stomach siya intended for absorption. So ano ang possible implication nito when it interacts with some agents or drugs? So meron siyang drug interaction na pwede nating mai-associate. Meron siyang significant drug interaction sa mga antacid preparations. Meron siyang significant drug interaction to antacids. How? Paano? Ang antacids, ano ang antacids? Being anti-acids, are they acids or bases? Diba? Aluminum hydroxide, magnesium hydroxide, carbonates. Yes, bases sila. So when taken, the site of action of antacids is in the stomach. They make the stomach basic. So pag tinake concomitantly or sabay ang antacid at ketoconazole, ginagawang base ng antacid ang stomach. Therefore, what happens to bioavailability of ketoconazole? Enhanced or reduced? Yes, so reduction of oral bioavailability. That's why this is a significant drug interaction. Did you get that? Gets? Good. Next, we have, what else do we have? Turconazole, then itraconazole, and then fluconazole. In the case of fluconazole, ito yung kanyang, solution dun sa problem ni ketoconazole, that is hindi affected ng pH, whether high or low, yung kanyang oral absorption. Okay? So for additional information about azole antifungals, you can check the information found on your book. So kasama to sa babasahin nyo sa mga specific examples. So nakalagay na yung page number. Sa ebook ito, sa actual book, hindi ko alam kung anong page, pakihanap na lang. But it is found on page 24 from pages 1085 to 1093. Madali lang yung kasi bulleted type lang siya. Pakibasa, kasama siya either sa exam or sa task if ever. Depende kung saan ko siya mailalagay. So yan yung mga further readings na gagawin nyo sa specific examples. So overall, tapos na tayo sa azole antifungals. So natapos natin ang azole antifungals.